In lesson 3.4, we're going to be talking about perpendicular lines. First, we're going to take a little bit of time to talk about some bisectors. And I'll remind you, as we talked in chapter 1, when we bisect something, we cut it into half or cut it into two equal parts. If you take a look at our first diagram, here I have segment AB, and because of my two little tick marks, I can see that my segment is being bisected. They are showing a line, ray, or segment in a plane passing through the midpoint. Now when I look at this diagram, I can see that line L bisects my segment, line M bisects my segment, line M also bisects my segment. We know from previous discussion that our segment really only has one midpoint. But when I talk about segment bisectors, how many can my segment have? Well, would you agree I could draw a segment bisector here, I could draw a segment bisector here, or here? As long as I'm passing through my midpoint, I'm bisecting the segment. So the answer to that, we can actually have infinite segment bisectors. When I look at diagram 2, however, I see I'm still bisecting my segment AB because I have my tick marks, but this time my line L is meeting it at 90 degrees. And so we're going to refer to this as a perpendicular bisector. A perpendicular bisector is a bisector that is also perpendicular to the segment. It still is going to pass through the midpoint. However, looking at my perpendicular bisector, is there another possible line that I can draw different from line L that would be considered my perpendicular bisector? No, because even if I change the angle a little bit, it's not going to be perpendicular. So how many perpendicular bisectors can a line segment have? You can only have one possible. And I'll also note to you that if we had a point on my perpendicular bisector, let's say my point X, that the distance from A to X would have to be the same as my distance from B to X, right? So any point on my perpendicular bisector, they say, is equidistant to the endpoints. And we're going to talk later about how we would construct a perpendicular bisector. Down below, as I look at my third diagram, if I asked you to think about my point C, and my line down here, I'm going to call this line L. If we wanted to travel from point C to line L, and I'm asking you if you wanted to travel the shortest path, which path would you travel? Would you want to go C to A, C to F, C to E, C to D, or C to O? Well, clearly we can visually see that the shortest path would have to be C to D. Why is that so? Well, that's true because it meets that line at 90 degrees. So the shortest segment from a point to a line is perpendicular to the line. This fact is used to define the distance from a point to a line as the length of the perpendicular segment from the point to the line. A lot of times you'll hear that stated as the shortest distance is along the perpendicular line. In example A, they're asking us to think about the shortest segment from point A to my line BC, and then to write and solve an inequality for x. So we had just said the shortest segment is going to be along the perpendicular. So my shortest segment is segment PA or AP. And if I wanted to write an inequality and solve for x, well, they're going to be pretty basic here. We know here that our shortest segment of 12 would have to be less than my segment CA of x minus 8. If I were solving this for x, we know we want x by itself, so we would there again add 8 to both sides. We would find out that 20 is less than x. Now a lot of times we'll see these with the variable written first, and that's what I would like you to do today. So 20 less than x would be the same as saying x is greater than 20. We simply flip everything around, and that's my inequality. Okay. On the back side, we have some theorems. And if you take a look, we're going to look at the diagrams here first. In my diagram, I can see I have line L and line M, and they're showing me that these two angles are congruent. Now, if they are congruent and they are a linear pair, what is going to have to be true about those angles? Yes, they're going to have to measure 90 degrees, right? So if this is the case, what is my conclusion? Well, my conclusion is that L must be perpendicular to M. It reads that if two intersecting lines form a linear pair of congruent angles, then the lines are perpendicular. In the second picture, I see, well, I have line N and P that are parallel. And I have line N and Q that are perpendicular. Well, what is going to be true if this angle is 90 degrees? Would you agree with my parallel lines and corresponding angles? This one's also going to have to be 90 degrees. So in conclusion, Q must have to be perpendicular to P. So in a plane, if transversal is perpendicular to one of the two parallel lines, it is perpendicular to the other line. In box 3, I can see that I have my lines R, S, and T. And while I don't know anything about R and S just yet, I do see that R and T meet at 90 degrees, and S and T meet at 90 degrees. So this would kind of be the converse of that. If both of these have 90-degree angles, which is showing me actually my corresponding angles being congruent, we would be able to conclude that line R must be parallel to line S. If two coplanar lines are perpendicular to the same line, then the two lines are parallel. Down below, we are going to do a little bit of solving. I'm looking to solve for x and for y in my diagram. I can see looking at my diagram that they do tell me I have some parallel lines. I also see I have this 90-degree angle. Now sometimes kids might say, okay, if these are parallel and this is 90, we said these would also have to be in 90 degrees. And if I looked at my first equation, well, I might say 6y is going to equal 5x plus 4y. And that's true, but with two variables, I can't do anything to solve. Or maybe we even see that 5x plus 4y is going to have to equal 90. That is also true. But I don't have enough information to solve for x or for y. However, here, I can look at my other equation and see that we can also say 6y equals 90. So in this case, we're going to want to solve for y first. And so we can plug it back into solve for x. We're going to find out that y is equal to 15 degrees. And now I'm able to take and I'm able to substitute that into my second equation. So we can say that 5x plus 4 times 15 must also equal 90, or that 5x equals 30, x must equal 6. And of course, we could always check that answer by substituting it in. Lastly, I want to take a look at example C. And example C is more of a review question, but it's going to review solving some system of equations. We talked about it briefly in lesson 3.2. I want to talk about it more today. You'll see that in example C, I don't have parallel lines. I don't have perpendicular lines, but I am solving and I'm looking to solve for my value for x and y. So by vertical angles, my angle measure here is going to have to be 72 degrees. And this angle here is going to have to be 108. I see that with my linear pair. So I know that my two equations that I can set up, I can say, well, my 2x plus 4y needs to equal 72 degrees. And 5x plus 2y needs to equal 108. Well, last time we talked about using the elimination method, and that's what I'm going to show you here. So I'm just going to write that. But in this case, I don't have a variable that would drop off or cancel. And so I'm going to have to do a little bit of manipulation. I'm going to use the multiplication property of equality, because what I do see when I compare is that I can eliminate my y variable pretty easily by taking everything and multiplying it by -2. Now, if I multiply by -2, I have to multiply both sides of my equation by -2. And I have to make sure it goes to each of those. I distribute it through. So down here, I'm going to take, my top equation is going to remain the same. So I'm still going to have my 2x plus 4y equals 72. Underneath, I'm going to say negative 10x and a negative 4y equal to a negative 216. Now, if I add them vertically, I can see that that's going to work out pretty nicely because my y, 4y minus 4y are going to drop off. I'm going to be left with negative 8x equal to negative 144. And divide, and we find out that x is 18. Now, as before, if x equals 18, I can go ahead and I can plug that back into my equation. I could pick either the top or the bottom. I'm going to choose the top one for no particular reason, but I'm going to substitute in that 18 and solve for y. So we would subtract our 36, divide by 4, and we end up finding that y will come out as 9. And of course I can check that answer by plugging it back in to make sure that I get my 72 degrees and my 108. Now the elimination method is only one strategy for solving a system of equations. If you wanted to do it graphically, you could. But the other way that we can solve this is we can go ahead and we can use what they call the substitution method. Now, if we're going to use the substitution method, we're actually going to solve one of our equations for a variable. We're going to isolate one of our variables. And so I still have my two starting equations. I have 2x plus 4y equals 72 and 5x plus 2y equaling 108. But what I'm going to do is I'm going to take this top equation and I'm just going to solve it for x. So I'm going to get x by itself. And if I did that, I know I would have 2x equals 72 minus 4y, or x equaling 36 minus 2y. Now what I'm going to do is I am going to substitute. By substituting here, I am only going to be working with my y variables. So I'm going to take this equation and substitute, but instead of saying x, I'm going to say 5, and I'm going to substitute in my 36 minus 2y, plus 2y equal to 8. Now we simply just have to do some distributing, simplifying, solving, and we'll be able to figure out the y value. And I can see here, this is a good thing. My y is going to come out as 9. Obviously, we should get the same answer that we got when we did the elimination method. If my y comes out as 9, again, I'm going to take it and I'm going to substitute it in. I can take either equation, the top or the bottom, it does not matter. When I worked through this the first time, I just picked the top equation and set it up as so. And when I went through and I solved, I found subtract, divide, and x comes out as 18. So there you have it. When you go to solve your system of equations, you can choose from either using the elimination method or the substitution method. It is up to you. Sometimes depending on your equations, one way might be easier than the other. You just have to do a little bit of evaluation.